Hey everybody, how's it going? Today I'm going to give you a full walkthrough on how to submit to Kaggle competitions. So basically you need to go to kaggle.com/competitions, which shows you all of the active ones. As you can see here, these ones have money prizes. So if you were to win or very close to winning, you may get a cash prize. But for most of these, don't really worry about it. We are not going to do those for today. What we are going to do is one of the ones that is always running, which is regression. Okay, house prizes, advanced regression techniques, you gain knowledge. Yay. No, you really do though. Okay, so it gives you the description when you click on it. And it says start here if you have some experience with R or Python. We will be using Python and machine learning basics. If you don't have machine learning knowledge, don't worry. I'll show you all of that too and explain most of what's going on. Maybe not into the complete entire detail. You would take a course for that. But I'll give you most of the information that you would need. And so that's the description. Basically, we're trying to predict California housing prices. Each row of data has a bunch of features on a housing area, and you're going to try and predict what a house in that area would be, basically. We'll take a closer look very shortly. So evaluation. Okay, so it is your job to predict the sales price for each house and for each ID in the test set. Okay, so each row or each house has some ID. You must predict the value of the sale price variable. Okay, so that's just a way of saying what is the price that we should be, what is the best possible price, okay? And although we can't see it, in the training set, we'll actually have this column because we're trying to map the input to that output. But in the test set of information, you're not going to have that column because if you did, you would just copy that sales price and your submission would be completely accurate. They're never going to give you the output variable in the test set because your job is to train a model on the training set and then use that information to try and predict on the test set. You'll still have the variables or input features in the test set to make the prediction, but you won't have the actual output variable. Okay, they are evaluated on the root mean squared error, so don't really worry about that too much. We're just trying to make a model that can accurately predict on the test set, and that column they're going to be using, it doesn't really matter what error metric, it's just we're predicting continuous values. So this is a regression problem, and this is probably the most common metric to evaluate this type of thing. Okay, so it looks something like this. This is the submission file format, what you need to send to them. We'll do that at the very end, but the file should contain a header and have the following format. So it should have the word ID and then comma sale price. It should have all of the IDs with their corresponding predicted sale price. So with this ID, what do you predict the sale price should be? These are just example numbers. Okay, this is their submission. We probably won't have the same numbers there. And yeah, that's the idea. Okay, so let's get started. We probably won't win the competition. I'm gonna let you know that right now, but we will join the competition. You need to make sure you've joined the competition, and then you can go into code here and then do a new notebook. Okay, so it's going to spin up one of their Kaggle notebooks. Technically, you don't actually have to use the Kaggle notebook environment if you really don't like it, but we certainly are going to use it for this tutorial. And we're going to call it, we'll just do today for me, it is April 23rd. So we'll do April 23 Advanced Regression Notebook. And let's get going. Okay, so it has all of this stuff in here already. You don't really need most of it. It does do some explaining and import some libraries for you. We are actually going to delete all of this, and we are going to delete all of that, although we'll probably talk about what it says shortly. So import OS, and then it's just going to walk through the file system in Kaggle. We're going to run this cell as is. Okay, so it outputted 4 lines there. Sample submission.csv, data description txt, we won't really look at that. Train CSV, so this is where the training set is, where you do have the output variable, and test CSV, where you don't have the output variable. We're going to try and predict that. Okay, so this is where all the data is. We're going to make a new cell and we will use pandas. So import pandas as PD, and we will just get, say, train underscore df pd dot read CSV, and then we'll pass the file name. We're actually just going to copy this whole thing here. We'll copy that, paste that in, and then if we output, just write train df and run that cell. we should see it outputs the data frame. So we have an ID column. This goes from 1 until the number of rows, which is 1460 of them. And we have a bunch of information here, MS subclass, MS zoning, lot frontage, just a lot of different information which corresponds to that house, okay? So we have all that stuff. A lot of it's missing, okay? So not a number means basically we don't have a value for that, and we'll have to deal with that accordingly. The year it was sold, sale condition, all of this stuff, we don't really need to worry unless you want to make like a perfect, like a really good submission. You don't have to analyze all of the variables in detail that much. The one that's most important to us is the sale price. We have this value because in the training set, we'll base our models off of mapping these features, basing all of this information and trying to find a pattern between that and the sale price. But if we were to do the same for the test df, I will copy that and put that down here. We'll change that to test df, change that as well. And then just in the file over here, we'll change that to test.csv. We output that and we'll see something very similar. Note that the ID starts at 1461. That happens to be one after the last one in the training set. So 1461, and then we have 1459 rows in the test. A lot of information here. It'll be all of the same columns, but not all of the exact same information in those columns. All the same columns. And then the last thing, sale condition, we don't have the last variable there. Okay, it didn't even give us the column for it. We don't know what that is. We're trying to predict the corresponding sale price in the test data frame. That's the whole point of this Kaggle submission. So let's start by making a really, really simple model. So right now we have the sale price for everything in the training set. Well, something that will not do very well, but at the same time is better than just a random guess, is the average of all of these values. Okay, if you took this one, that one, you summed everything up here, then you divide it by the number of them, you would get the average. You could also do like the median. We could compare those. We're just going to do the average. So to get the average in the training set, well, that's pretty easy. We have train df, and that final column there, that's called sale price. So train df, and then square brackets, sale price. It is .mean in pandas. It's pretty small there, but the number is 18,921. That looks right to me. I feel like that's right in the middle of all of those values. So 18,921. Well, it's again, very silly. We're going to use none of the features involved at all. Features meaning these input variables, all of this. We're not going to use any of those. We are just going to simply predict for each of the IDs in the test data frame. We are simply going to replace, we'll just make a new column and we'll call that the same as the other one. We'll say test df sub sale price. So that doesn't exist yet in the test data frame. We'll make that is equal to this thing. Okay, so whatever the mean was in the training set, and we'll just make that the pd.series of that information. Okay, so that way if we output test df, it's only the first one. Okay, so we just need a very slight modification here. It's train df sale price dot mean, except we need to repeat that value many times. So it's actually just this, and then right by the square brackets piece, we'll do times the length of the train df. Okay, so this way, what it is it's that mean value, and then we do it 1460, I believe, yes, we would do it 1460 times, so that same value over and over again. And so test df is now, no, that's invalid syntax. Sorry, I must have had a small error there. In the square brackets, pd.series, it should be like that. Sorry about that. And then we output that information. It is going to have the test data frame, sale price, every single value is going to be that average value. So let's submit that. Okay, there's no point of not just submitting it. Some things they don't allow you to submit over and over and over again, but this one we can just go ahead and submit. Daily submissions 0 of 10 used, so that's fine. So what's our submission look like? Well, it's very close to what test df is now, except it's actually just a subset of the columns and then a slight tweak to that. So we can do test df sub, and then the columns that we want the ID column, and we want our predictions as well. So our prediction is sale price. And if you just look at what that is right now, that is another error. Sorry about that. ID is not an index. It is actually called ID with a capital I, okay? So ID and sale price, well, that is extremely close to what we wanted. If you remember looking at what the file submission was, it was pretty much just without this column here, without this index column, it looked pretty much like that in a CSV. So we can actually output this to a CSV. We could do dot to CSV, and then we can specify the name of that first. So we're going to say just average underscore prediction, because it's literally just the average prediction.csv, because we're making it a comma separate values file. And then it'll actually mess up if you don't have this extra thing here. We need to specify that index is false, meaning we don't want to store this index column. So if we do that, it actually just runs, and it doesn't really look like it did anything. But if you go over here to Kaggle/working, we'll have average prediction.csv. So the easiest thing to do is just to download this file here, average prediction.csv. We'll download that and we'll take a quick look to make sure it looks how we want it to. It'll open up in Excel for me by default. And what it says here is really exactly what we wanted. ID column, sale price, and then all of those different values. So now that we have that, we'll just go ahead and save our file. So we can go here. I don't want to run it all. We'll just do a quick save. And I'll call this, I actually did a version earlier. This is version 2 now. Doesn't really matter. We'll save it as version 2. So we've saved our file. Now what we can do is go to competitions. Yes, I want to leave the notebook editor. We already saved it. Make sure you do have it saved. And then we're going to go here and find what we had before. Okay, so click on that again. We can go over here and do, I think it's in leaderboard, and then submit predictions over here. Okay, so it's saying all this stuff. The easiest way to do it is just to upload the CSV. So I didn't show that part for security reasons, but basically you would have downloaded that CSV earlier. You just upload that specific file again. You can describe your submission if you want to keep track of them. If you are working on a problem, you might want to do that multiple times, but we're just going to make a submission and it's not going to do very well, but that is how you do a Kaggle submission, okay? And it's really not very good. Jump to your leaderboard position. It's 3,945. Sadly, it's better than actually a fair amount of submissions, which is just funny because that's literally the easiest possible thing that you could do. It's probably only better than some of them because sometimes you accidentally submit something wrong. And so it's just, it's even worse than just the average. But that was our first submission. So honestly, not bad. It's nice how easy that is. Find our same notebook again. I'm just going to go to code and then your work. So you should already have your same notebook that you were working on earlier there. Okay, so I loaded that up yet again, and I'm just going to run the cells again. Run that, run that, run that, run every cell. Okay, so basically we go back to what we were before, and now the only difference, well, we just need to make some sort of a reasonable machine learning model so that it's better than the average. We're just going to try and beat the average. Any sort of reasonable model would look at the training set and it would try and figure out a pattern between the inputs and the outputs. Okay, so we're going to look at all of these different columns, not actually explore them in detail very much, although you could. We're just going to use them to our advantage to make a model. So we're going to make one of the easiest models that you can that utilizes the training data frame, and you can actually make predictions on the test set, and it should be better than the average. In this video, I'm not going to show you the whole process to make the best possible submission. You'll have to check out my other videos on some of the things that you need to know so that you can do that, but we're going to make at least a simple submission that makes more sense than the average. So we're going to do that with a few different columns in the training set. We will use the MS subclass. I honestly don't even know what that means. Part of the point of this is to get a basic solution. You don't have to know what everything means. We'll use the MS subclass and the lot frontage values, okay? You could potentially use all of these variables in many, many different ways, but we are going to just use this value and this column right there. Okay, so we will make one with that. We will make a data frame with those two columns. So we'll say train df subset, or just sub for subset. That is equal to train df and then those different columns. We are going to just go and copy those columns. MS subclass, I actually don't know why I'm going all the way up there. We'll do MS subclass, and then we will also get the lot frontage column like that. Okay, so that's just those two columns. And just to be safe, we're going to make a deep copy of this, which means literally copy over every single thing. You won't even really notice the difference, but it's important. We will do from copy import deep copy, and then we will make this actually a deep copy. So call the brackets like that. It's a function. We'll make a deep copy of that, and we'll see that train df sub is just those two columns there and the index column as well. So we'll start by making a linear regression on these columns that tries to map to the output column. Well, we actually also want that output column, so I'm going to grab that as well, and it was called sale price like that. And so now the sub also has that. So these are our input variables. We'll use this and this as inputs, trying to map those to the output sale price like that. Well, we're going to make a base linear regression for now, and it's pretty easy. So there's a couple things we need to do. We will do xtrain, because this is our training input matrix, calling it a matrix because it has rows and it has columns, so a matrix. Xtrain is equal to, well, we can convert this to a numpy array. So train df underscore sub dot to numpy, you just write dot to numpy, and that does it for you. If you check xtrain, what is that? It looks extremely similar. These are actually the same values. It's just outputting in scientific notation. So same values, just all of these things here, but without the pandas stuff like the column names and the index, just the information. Xtrain actually shouldn't be quite that. It should only be our inputs. So our inputs, we can get those, well, we want all of the rows still. So we'll do a colon for all the rows, but then the columns we want up until the last, not the last column, okay? So now what it is it's just those first two columns. Note that it started outputting normal instead of scientific notation. It's not really a big deal. It's exactly the same thing. We also need what we call ytrain. So ytrain is our output vector. I'm calling it a vector because it's just a sequence of values. I'd call this a matrix because it's rows and columns. A vector is really a matrix with just one column. It's our sequence of outputs. So ytrain, well, it's going to be the same thing as that. It's all of that, except then all the rows, yes, but then just the last column like that, so that you can see ytrain. So ytrain is just, it outputs like this, forward like this. It's all of our outputs. So now we have all of our inputs, we have all of our outputs, and we can make a linear regression on the inputs and map to the outputs. It's extremely easy. You do from Scikit-Learn. There's also other libraries to do linear regression. This is the most common one. From Scikit-Learn.linear model, we will import linear regression like that. And then we will do, we'll call it LR for linear regression is equal to a linear regression, bracket, bracket, and then dot fit. So we're fitting the linear regression. We're training the model. We train it with the inputs, xtrain, and the outputs, ytrain. And if you output LR, we're actually going to see an error. You might need a way of handling missing values, such as pandas.dataframe.fillNA or sklearn.processing.imputer. See our missing values tutorial. So what happened here was we were trying to make a linear regression, except some of our values were missing. It doesn't look like it from this small thing that we saw, except some of the values in here in the middle, they were missing. It could have been the MS subclass, the lot frontage, or the sale price. We needed a way to deal with missing values. Now, a very common thing to do is if there was any rows that had any column in it that was missing, well, we would just remove that row. And so whatever, say it was this row and say this value is missing, we would just remove that row. Now, this is a common strategy, but in Kaggle competitions, it's kind of a problem because the test data frame, what we're going to need to do for the test data is, well, we need to predict the sale price value. Here we use the average, except we have this for every single ID value. If we were to drop one row in the test data frame, Kaggle would yell at us later and say, hey, you're missing this ID, that's a problem. And so technically you could still do this for the training set because there's no reason that you need to include every single row when you're training a model. But we would want to use a similar strategy that we do on the training set and do that same strategy on the test set. And we can't really do that. We can't just drop rows in the training data frame. Then we wouldn't know what to do in the test data frame. So something that works well for both things is something called mean imputation. So mean meaning average, imputation meaning whenever we have a missing value, we so-called impute or just place in the mean. So mean imputation, impute the mean. Whenever we have a missing value, here we're going to calculate the average of this column, calculate the average of this column, and although we probably aren't missing any sale prices, we'll calculate the average of this column and replace any single spot. Anytime that there's missing a value here or here or here or here, we're just going to replace that with the mean for that whole column. Kind of similar to what we did for creating the test data frame. We shoved in the average here. It's just that everything was missing and we only did that one column. We'll do that here, and so that everything here is going to be complete. And so our machine learning model is going to, be slightly annoyed that we're placing with the average because it's not technically the right value, but it's a good guess. It's something, it's better than nothing. And a lot of the time it's better than just dropping information. Okay. So how do we do that? It's actually extremely easy. Right after we make the train df sub thing, we're going to add in a block of code here that just does that. It's going to make this equal to itself dot fill na, and then we need to get itself, so that same thing, dot mean. Okay, so the mean, if you see what that is here, it's actually very similar to before, but for the whole data frame, it is a panda series where it maps the input or the column to its average. Okay, so this is the average. 56 is the average of this column. Lot frontage has an average of that. Sale price has an average of that. We don't really need to worry about how that looks. That's just how it happens to be. I'll kill that cell. But we put that in here to fill in A, and it knows just by seeing that if you were to output this, it's not really going to look any different, except what we did is anytime that there was a missing value, we replaced it with the average. So we're just going to run all this again to make sure, starting from the deep copy, run that, then we will run this, we will run this, and it doesn't look any different, but here, LR, it actually outputted this time. When you regression, it just outputs, this isn't anything interesting. If we instead outputted LR dot coif, I believe it's 1f, it might be 2, coif underscore, this is the so-called beta 1 value, and this is the so-called beta 2 value, and it just matters for now that we got a working linear regression. So to explain a little bit about how this model works, we also need the lr.intercept. So lr.intercept underscore, these things together define the whole model. It's technically beta naught plus beta 1 x1 plus beta 2 x2. So this is beta naught, it's just the intercept value. This is beta 1, it's the first slope, and this beta 2 is the second slope. What does that mean? Well, we're proposing a linear model. So given any input, an input is defined by, well, we're saying we need an MS subclass and a lot frontage value. So maybe we had the MS subclass was 20 and the lot frontage was 62. Well, we need to be able to use that to predict a new sale price. So we are proposing, and we trained a linear model, which means we will take the value of the intercept, 88,327, and then we will add this value, about 76, times that input. So whatever you had for the MS subclass, we will multiply that by this value, and then we will add again. We will take this value, 1260, and multiply whatever value was for the lot frontage. So it is beta naught plus beta 1. This is beta 1 times the corresponding input plus beta 2 times its corresponding input. Whatever you gave it, some input for the MS subclass and some input for the lot frontage, we're going to take the intercept, add this times the MS subclass plus this times the lot frontage value. That gives one value, and that is our predicted sale price given the linear model. Okay, so let's say that we did have these inputs. We had a 60, so it should be the 88,000 plus 60, and then times whatever the LR coif was. So this value, sorry, that should have one more. We'll just say 76 approximately, plus, and then we will get the 65. Okay, so this is 65, and then times the 1260. Okay. And then we will add the intercept, so 88,327 plus this. All of that, this would be our predicted price given the linear model. Why is it 3,000 off the actual sale price? Well, our linear model, it's not going to fit the data perfectly. The whole point was not to get the inputs and find an output that will correctly match the exact output that was actually in the training set. We have an approximation. So we have a linear model. It's going to be inaccurate. It's going to be a bit wrong. Let's see if it's better than the average at least. So how would we measure that? Well, we can get something called an error metric, which is also similar to what it's using behind the scenes for the Kaggle competition. From Scikit-Learn.metrics, we will import, well, they were using the root mean squared error. We're actually going to use something called the mean absolute error to make our metrics. It's just for fun. You could use a lot of different things. This says on average, exactly what are we off by? Okay, I'll explain that shortly. If you get the mean absolute error of, well, first we need the training set predictions. So we are going to get a new column here that says on the training set, what would we predict? So that way you could check the difference between the actual sale price and what we predicted, and then the difference between the sale price and what we predicted. And then you could actually add up all of those differences. That gives some sort of an overall metric saying, hey, we're off, or our error is this much. And then technically, we're not just going to use the sum of those differences. We are actually going to take the absolute error, which means you take the distance between this value and whatever we predicted. That is either positive or negative, depending on if it was higher or lower. But we take the absolute error of that, so you get some positive difference between the two, and then you sum up all of those errors, and then you divide by the number that we have, so that on average, it's saying on average, what's our error? On average, what are we off by? Well, we can do this with, we're going to add in that new column. So we have train df sub. We'll make a new column. We'll say linear predictions. And that is equal to, how do we get a prediction for each column? Well, we have our input matrix here. We have xtrain. So all we need to do is do our model lr.predict on xtrain, and then train df sub. That has a new column of linear predictions. It says this value and then this value. Well, that has this actual sale price, but according to our linear model, it's guessing this and this input and this input actually has a sale price of this. Our linear model guessed this. Here you can see that it's lower. Our prediction is lower than the actual. Here you can see that its prediction is higher. On average, we're going to kind of be off. Sometimes we'll be higher, sometimes we'll be lower. It just depends on the input. Okay, so let's get an overall error metric. Mean absolute error of it's just these two columns. We can pass it in like this. We can do train df sub, and then say the name of this column, the sale price, and then we can also get in a separate thing, we will copy that again, train df sub, and then instead of sale price, we'll do linear prediction. Really, it should not have an S there. That's kind of weird. It should be linear prediction is that column. And it actually made a new column. That's fine. We'll do linear prediction. We'll get the mean absolute error. It's saying on average, we're off by 54,381. Well, that's not very good. That's off by quite a bit. Now in this video, I'm going to leave the metric at that. And normally you would actually do a lot of research into looking at these metrics, but in this video, I'm just going to show you that that's the error from the linear model, and we're going to use this linear model to make a prediction on the test data frame and see how that compares to our earlier submission. So what will we do? Well, we need to get the same stuff as before, except the only limitation that we have is that we don't have the sale price column for the test. That's okay. We're going to use the same linear model that we trained earlier that was trained on the sale prices from the training set, and so we don't care that we don't have this column. We are just going to grab the inputs from the test data frame and use those to make a new column that has our linear prediction. So we'll start by getting the same thing as before. This gets the sub on the training data frame. We are going to get the subset on the test data frame. So we will remove that column because we don't have that column. We will remove that, and then we will make this, say, test df sub and test df sub, test. And this should come from the test data frame. And if we output that, that is all the variables for the test. Well, now what do we do? Well, before what we did, we ran into an issue with missing values. Just in case we run into that again, we will do the same thing before. We could do it with the train data frame mean, but we're actually going to do it with the test data frame mean. There's a slight difference between the two, but it doesn't really matter. We'll do test df sub. We will make that equal to the test df sub dot fill in a with test df sub dot mean. So really the same thing, but with all the test stuff, and we will output that. It doesn't look any different, but if there was any missing values, we replace them with the mean. Okay, what did we do before? Well, we split into X train and Y train. Well, we're not going to get a Y train because that relies on that sale price, but we will do the same to get the X train. It's actually very easy, so I'm not going to really copy that. What we do instead is just say that X test, so the input for the test, that is equal to, well, we need to convert this to NumPy. So we will get that whole data frame and then dot to NumPy. And that's all that we have to do. X test is just that array, and that's totally fine. We can make predictions off of this. So we will do test df, and then we will replace the linear prediction. So we'll make a new column, call it linear prediction. So test df sub linear prediction, that is equal to the LR, our linear model, dot predict on the X test. So that test df now has this column way in the back here, which has a linear prediction. Okay, so here's our average prediction before. This is with the linear model. Note that these are all different because those are based off of these values here. It's based off of the MS subclass, and it's based off the lot frontage. The rest of these columns, we didn't actually use those, but we'll still leave them there for fun. And here's our corresponding linear prediction. So now we need to do the same thing that we did to get our submission. It was not hard at all to make the submission. We just need to make it a CSV file. So we will grab this. That's the thing that we used before. Scrolling down, sorry for the headache there. We will do test df sub ID and sale price. Well, that's actually, we need that to be linear prediction. We'll output that to a CSV, and we'll call this a linear prediction, basically. Okay, so sorry, I am back in the notebook, and I am just going to go in, and at the very last thing, I'm going to call this test df here. We'll just overwrite that sale price column. Before it was the average. We will now make it that new one. I do have to make sure that everything has run, so I'm just going to do a run all. It shouldn't take too long, and we should see here, just making sure that it's actually run everything. Okay, sorry, got an error. This should also be sale price here in the very final line. We run that, and it should have updated our file called linearprediction.csv. We'll download that and do the same thing. Okay, this time when I did it again, it actually has a bracket 1 here because I had to download it again. It doesn't really matter. We'll make that submission, and it scores it, and it gives us a 0.397. Okay, the most important thing is that this was lower than it was earlier. If we jump to our leaderboard position, I actually had to reload the page there. It was giving me a bit of an error, but after you submit it, it should say that this is an improvement. It was 0.425, and it's now 0.397, which is better than what it was previously. Lower is better because the overall error metric, the higher means you have more error. The lower here, that means we have much less error. So that's better. So there you have it. That's how you submit to Kaggle, both through something simple. We'd actually call it a baseline model, that average model. It's something that, kind of makes sense. So a baseline. So then we improved on our baseline model by making a model that actually trained on the training set. It learned how the inputs mapped to the outputs. We used a linear model. You can, of course, use other models. And then we used that model to make predictions on the test set, and it did a better job, and generally it will. Now, next steps for you. If you haven't actually learned all the machine learning stuff, like say train, test, and validation sets, various different models, I have lots and lots of different videos out there. Make sure you check the playlist that I have in the description. There's also some really great Coursera materials that I have linked down below as well. And you can use those techniques that you learn to make a better model and make sure that your model is better before you submit it. That'll make sense once you actually learn those things, and then you can get better and better models and get better scores. Then, of course, you can go and actually look at other competitions. So once you get really good at this stuff, you can go and do very similar ideas for maybe you can try some of these ones, or at least all of the other ones that don't have money associated and they're just kind of always running. Go ahead and try and do those and work up your Kaggle profile. It's a lot of fun. Okay. So I hope this helped. If this did provide value, please consider dropping a like. I'd really appreciate that. If you're not subscribed to the channel, then maybe take a look at some other content and consider staying up to date. And yeah, I'll see you later, guys.